Hey, everybody, welcome back to another edition of Transformation Leaders Podcast. I'm David. My co host Sean is with me today. And today we're going to talk to you about edge computing and AI and all of that wonderful stuff in between. And to assist us with this, I will bring up a deck kind of talking about a little bit about the edge use cases. So, as always, there's lots to talk about and a lot to dig into. So, Sean, kind of start us off with, talking a little bit about edge before AI, just to kind of build a little prerequisite knowledge for those that may not be familiar with edge computing.
Yeah. So, there's a lot of things can be done online, right? People are spending more and more of their time online, but there are a lot of people who like to have actual physical experiences still, right? So think about it. In 2 weeks, I'm going to be in Disneyland, right? These are physical experiences that you want. If you're going to go to the movie theater, right, to watch a movie, that's a physical experience. If you're going to go watch a football game live, that's a physical experience. So these things are trying to be brought forth into those experiences, technology, I mean. And that's where people talk about IoT. This is where people talk about the edge. The edge is the opposite of the cloud. That's what the edge is. So how do we create better and better experiences in the physical, non-online realm? And that's really what we're going to be talking about today. So, it comes down to the challenge at the edge is that you have to do things close to home. And before, it was incredibly expensive to use AI because you would need to have a very powerful system at the edge. That model will need to be created by machine learning. And if data changes or if somebody throws it a curveball, the whole thing falls on its face.
Yeah.
So, people talked about, well, why don't we go through and we will use AI in the cloud and have the edge experience connect to the cloud. Well, then you have a bandwidth and network dependency that you didn't have before. So a lot of things went wrong in starting 2 or 3 years ago during the pandemic. We had horrible supply chain issues with IoT. But now things are changing. What we are seeing is new techniques with Gen AI. And I call everybody out. If you haven't heard about DeepSeek and what they did with distillation, David, do you know that story?
Yeah, I do. It's pretty clever, but at the same time, it's going to give the intellectual property lawyers a run for their money for sure.
Absolutely. In fact,
if this falls out, it's going to be remarkable for the next 5 years, I'm sure.
We should put a note, because I know as somebody asked about that, the copyright issues with large language models, and having a primer on that, because I do know there is a court case coming up on it. But in the grand scheme of things, what that open source model taught above all else is that there is room for distillation, so that you could take a very large model and create a small language model. And that small language model can run on much smaller hardware. And that's the key, because if we could shrink a large language model to run on a Raspberry Pi that costs $100, that is, 3 inches by 2 inches by 1 inch, and uses 50 watts of power, right? Then this becomes much more a reality.
This is true. The other thing too I wanted to mention real quick is that a lot of times you'll have these edge appliances picking up information and data, usually censored information, not always, but usually most of the case. and there's a fire hose of data that's just being pumped into the back end. So one of the things, as we always have said, um, it starts with back to the last slide where we talked about the optimization aspect of it, is if you don't have your ducks in a row data wise, all this is going to do is send everything into an extra layer of tizzy. So make sure you have your data clean, make sure you have everything ready to go. Otherwise, this next part, garbage in, garbage out, does it applies even more to a magnitude of, exponential proportions, unfortunately.
Yeah. So the number one thing that we're seeing at the edge is when people are saying, I want autonomous decision making. So imagine, if you will, you're going to Disneyland and you go into the park and they need to separate groups of people into different cars, right? And right now, that's a human doing that work. But imagine, if you will, there was a kiosk that was doing that. That was taking pictures and it's saying, you guys do this and you guys do that. Well, the chief issue with that is the network reliance. If that network were to go down and you're using a cloud AI, you've got latency, you've got time, you've got power requirements, but more importantly, availability. You cannot stop working if your network isn't working that day. I know the advent of private 5G and those kinds of technologies, but what we're seeing come about really quickly because of the distillation concept that DeepSeek brought to the table, that you can effectively bring a large language model and decision making into a self-contained experience. And I'm throwing out Disneyland being cheeky, but you can also think of this as you're wanting to you're a casino and you want to route people around, right? So you want to close certain entrances and exits to route people around certain things that you want to do. Maybe you want to do something like with industry and industrial, right? You're trying to manage the workflow through multiple different lines of supply and demand at your shop floor. So all of these things are reasons why you would want autonomous edge decision making. So can you think of anything else, David, that I didn't, as far as use cases?
In this particular example, not so much, but I will say that when it comes to these, algorithms, just to kind of simplify that, because I remember one comment that we had got. It was a somewhat technical, but not quite a technical individual. And that algorithms are nothing more than just patterns. A lot of times people think that mathematical experts need to create algorithms. And while that is true, this does happen. It's a type of algorithm. And an algorithm, as it applies to your business in plain English, just says, you look at your workflows or your processes. I do A, then B, then C, then D, and then whatever. Maybe there's some math involved in it. Otherwise, it's just a series of steps. And that's all an algorithm means. So when it comes to wrapping your head around it, that if you can get at least to that generic understanding of it, it will make planning and strategy so much easier for you, because you're not trying to be turned off by, oh, I don't know all this complicated math. This is only for my IT or technical teams. And that's far from the case.
Yeah. So the use cases are very different for everybody. So I mentioned some around the manufacturing space, retail, like, for example, everybody should remember like Minority Report and Blade Runner, where you're walking down the road and you're getting advertisement personalized to you, right? This is your Google ads in the world. This is the technology that's going to unlock these type of experiences. Or when you come in and you sit down, it will automatically take your temperature. It will automatically link up to your personal devices and get your health information, right? There's going to be a whole different avenue of different in-person experiences unlocked by having generative AI in the field.
Yeah. Sean and I were talking backstage when it comes to talking about retail. And while this is most effective for businesses and companies and marketers, there's this persona, I guess, or perception, maybe a better word, about consumers kind of revolting against this type of thing. However, if done ethical, if done right, it can really benefit everybody on both sides. So there's nothing better than having what you need at your fingertips when you need it. Maybe a little bit unnerving as to how that came to be, but nonetheless, as long as this stuff moves forward, and the key takeaway is here, we all have to do our main parts here. One of the previous examples that I have before AI even came onto the scenes is there's a company called ABBA or ABBA, and they do controllers for HVAC and other types of things in manufacturing. And so they have been primed and set up in the manufacturing industry with edge computing just being part of the solution forever in 5 days. And now with AI. So if you're looking at this and you're in a small manufacturing setup and you don't think that you can use an edge AI use case, everybody of any size, I don't care if you're a large corporation as big as some of the major healthcare providers here in the United States, into the major manufacturers, or even a small mom and pop shop that might have distributed manufacturing. I don't know. Let's just say they've got all these, what is it? We Create with those laser type printers. But if you've got a distributed work group, you've got people, your company, you might have 3 or 4 of these things throughout the United States. And, you'll kind of want to pick up on what's going on so that you know where to distribute these jobs as they come in. And so with that telemetry and the sensor data, but my key point is here, you can take a Raspberry Pi, stick that edge compliant device on one of those items. It can feed its telemetry back into the algorithm, which basically is just looking up how many jobs are in the queue. Is it overheating? Does it look healthy? Is the machine throwing any errors? So you take in all of this plethora of information that you throw into this hopper, and then you say, I need to account for all of this, and then show me the best place to stick this new order so that we can have the highest amount of production. So it's a stupid use case, but it's a small business concept that can be brought to the same level as what manufacturers are doing. If you're, and usually we don't mention names, but think of popular soft drinks, the red can, or even the white and blue can, those types of use cases. They've been doing this stuff for years anyway. And I personally haven't been in each of those manufacturing facilities, but I can almost guarantee you that minimally on the back end, through all of this data, and then usually most companies, and I can never think of the Splunk, that's it. Systems like Splunk or Databricks or things like that, right? They now have AI baked into these back-end systems. So they're already looking at this type of telemetry. So if you think that it's not available to you or it's fringe or use case, because edge computing is a kind of a scary word to you, but when you consider adding AI into that, it kind of kicks it up and takes it to a whole new level. You should definitely not discount it because you need it to help understand this information and give you the analytical insights that you need. And I think that's really a key takeaway, is the analytical insights that AI can give you on this enormous amount of data that is just mind-numbingly large.
And I mean, a lot of people will say that, the enemy of big data is big data, right? Because if your data is so big, it is hard to traverse. You're not going to have a lot of outcomes. But if you are collecting data, right where you're collecting data, you are making decisions, you are making assumptions, you're validating those assumptions, and you want to turn that into actions in low latency, meaning less than 5 minutes. This is where things come into play. So, and this is the whole point. Again, we're really doing a good job segueing. So reduced latency is really why you want to transform at the edge. Maybe it is a life and death type situation, and that's where latency is so important. But I'd like to think of it more in the hospitality industry, right? Where you're on a cruise ship and you want to order a drink, and then it will route the drink order to the bartender who is free, right? And then tell the people, hey, go pick it up at the bar. So by the time they're walking, the person is doing the work, and then so that there's less latency from the experience perspective and less downtime from the person who actually has to do the orders. Being able to track those orders and be able to, let's just say, call people up to certain bars that need help and do resource allocation. There's all these kind of ideas that you can do at the edge because you have that reduced latency. And maybe you're in the middle of the Pacific or tooling up to the Arctic, and you don't have network, or you don't have reliable network, or the network's too expensive. So there's plenty of reasons why to do this. Now, the privacy and security is another wonderful thing, because to your point earlier, what if people are worried about their privacy with this, and that you're not allowed, because of GDPR or HIPAA or some other compliance, to even store this personalized data. But what you can do is you can use it in real time to make an impact and then delete it immediately, so that you're not storing the private information. You're using it to help them immediately.
Yeah, I think one of the good use cases to that is, assuming you have, and I'll go back to the chintzy Raspberry Pi example, because I think most people at least have heard of a Raspberry Pi, or at least understand it. It's just this little tiny small compute about the size of a phone. But the key here is using that data in real time. If you can apply an algorithm, like if you know what pieces of data go together and you can analyze and package it up in such a way, and maybe there's some AI that you need to provide some additional instant classification or trend analysis or whatever the case may do, you're using AI at the edge with the telemetry data as it comes in, processing it, and its final step in the algorithm is to send it through the pipeline that it normally goes through. Now, of course, this thing's going to be going brrr or whatever, but that's using it literally in real time in a very good and interesting use case. And obviously, especially with HIPAA and GDPR, you'll want to have a large or small language model as your AI componentry on that edge device to do this in real time. So there's definitely all these gotchas, but the point here and takeaway is that's an example of how you would do that. And also to know that it is quite possible to do it, not just theoretical.
Yeah. And again, I talked about the big data enemy is big data. Let's say we're tooling up to the Arctic. Do you really want, how many people are walking on this deck during this minute to be sent using the most expensive network when it's completely useless after it's been done, right? So you could summarize those and send the summaries to the cloud, but in real time, why store that data? Why ship that data? Because you're just going to have to get it back later. Using efficient amount of bandwidth is a good idea, because it is a finite resource, and that resource can be quite expensive. So, there's plenty of reasons to do this. So the problem is, when it comes down to the edge, is that you have to live within your means, as I tell people.
Yeah.
And the means are the business feasibility of the hardware you're going to be using. Now, fortunately, Moore's law is always in effect. So every year, these things get easier. Raspberry Pis or quad core, and now they're octa-core. Basically the same price. They were 4 gig, now they're 16 gig. You can go through and buy a Dell small form factor desktop that's Intel, and it is low, like 150 watts, and 16 gigs of RAM. So there's all kinds of hardware that you can use on this. And as we're talking about AI, it is getting easier and easier. I know me, I bought a $400 mini desktop online from Amazon with 64 gigs of RAM. And I'm loading 8 different full large language models, 8 billion to 16 billion parameter large language models. And I don't have any GPU on it. Yep. So if you've seen NVIDIA's talking about their Jet platform, and I think it used to be called Jetty, and then Jetson, and they're using lots of those terms. They like the word jet, but they're evolving that platform because they understand at the edge, it'd be really nice to be able to have something that's really high powerful, low wattage, low cost. If you call $1,500 low cost, but if you imagine, the Disneyland example, where the kiosk is run by one of these, $1,500, which is, as far as per hour cost is in the pennies, compared to hiring a high school graduate who could sit there and learn how to count, right? It's hard to find the people who want to work those jobs. Not to mention all the logistics that comes from having those employees. And if we can automate it while elevating the experience with AI, perhaps we can use those people to do something much more than just count. That's the AI concept. I think we've talked about it many times. Have AI do the things that it does well and it does cheaply, and allow the humans to have more of a personal experience with people, because that's really what's going to differ. Nobody wants to be treated by a robot, right? But the robot can help the human elevate the experience without making their job monotonous.
And as a customer, I just had a horrendous customer experience yesterday. I won't mention any names, but a large hosting company, they sink a tremendous amount of money into advertising hosting. But when it comes to their customer service, it's non-existent. It's all AI. And there's like 3 people that seem to man the chat, all globally outsourced, resourced, whatever. And it's horrible. Like, you're trying to run a business and doing cloud hosting, there's no help. It's all AI, and the AI is horrible. It's bad. It doesn't, I'm pretty technical. So when it comes to a problem, usually I need help. Like, somebody has to fix it. And it took me 5 hours to finally get to the point of making a ticket. That's an example of just don't do that.
Oh, absolutely. And again, this is the whole thing. I don't believe the fallacy that AI reduces headcount.
No,
I don't. And there's plenty of reasons, and we've talked about those reasons before. If you're looking to elevate the experience, which I think everyone in the area that you're talking about is in that camp, right? They want to make people understand that their brand cares, that their brand is looking out for them. They want to be able to elevate that experience. And I think AI, whether it be at the edge or in the cloud or anywhere, really has that ability. So, but we talked about the resources and the connectivity. The problem with having something at the edge is, what if somebody steals it? What if somebody runs over it? What if it rains on it? What if it freezes? What if it gets too hot and breaks down? So the complexity at the edge is not alleviated by AI.
No.
And then we talked about this a little bit earlier as far as optimization. So you want to use the most efficient model that uses the least amount of horsepower, that provides the necessary experience and no more. And threading that needle means that you're going to need somebody to help you through that journey. And why I mention that is because that's the stuff that we regularly do. Is every week, if you go on Hugging Face, the models change. And those are just the base models. You know, most people, they're going to want to augment the data found on the internet. So really good opportunities to do things like this. And again, we talked about distillation is a new trick that people are going to be doing more and more. So we had embedding, then we had fine tuning. And I think distillation is the third step on that tree to allow people to use large language models in a much more efficient way. Because if I'm in Disneyland, I don't need the large language model to know how to do open heart surgery, right? I don't need it to do understand what the what every city's population is in a far-flung nation of the world, right? All of that stuff is in the large language model. You know, politics information. Nobody's going to want to understand or hear that in Disneyland. So, you know, it comes down to if you can reduce the size of your large language model, so it's a small language model to fit your bespoke needs, this is extremely powerful.
Yeah, let me throw a couple of cautions and possibly even go into a small little mini breakout, because this is a source of confusion, not only for questions that we get here on the podcast, but just questions that I get internally and in talking with customers. There's just this massive amount of confusion, because you mentioned Hugging Face, and a few people watching this, especially on the leader side or leadership side, they may have heard about it, but they're really not quite sure about what it is. Essentially, it's a Apple App Store or Google Play Store for large language models, where you go to get your AI toys. Where this is like where all your developers and all the geeky people kind of go to hang out. Now, to use when you hear terms about distillation and things of that nature, and quantization and all this other stuff, you need to be kind of cautious or careful with that, because at some point there's a diminishing set of returns that come out of that. A good example would be you go to a bar, you order some, I don't know, a Macallan 18 or something, right? Really good, nice Scotch single malt or something. And then what happens is, unbeknownst to you, they water it down a little bit. The next day you come back and you're like, you don't really notice it. But by the fifth day, you're thinking, man, my taste buds are off. I ate something wrong, but this just doesn't have the same flavor, the same taste, the same punch. And at some point, you either use too many bits in your quantization or ran multiple layers of distillation. And at some point, it's functional, or it gives illusions that it's working, but it doesn't really quite work. So you really, really, really need to be careful how you go through your implementation of that, because at some point, again, you're going to water down the Scotch.
Yes. And again, testing and having humans test. I know test automation is a big thing, and I am very happy that test automation exists.
Yes.
But it does not replace the smell test.
Nope. You need to have your rubric built in your QA of saying, these are our mission critical algorithms or approaches or tasks or things that we do. So as you do it, as long as they pass the sniff test or pass the use cases, then, you know, and the other thing too is I would say keep 4 to 5 iterations of the steppings of whatever you've done, so you have a point in time in which to go back. And 5, in my opinion, seems to be the sweet spot, because let's use what Sean had said, for example. Let's just say through distillation, somehow you convince the large language model to ignore and drop all of its political nomenclature and approaches or understanding or whatever, right? And it clears out, I'm just going to make up a number, 25% of this model. And if that's the case, what you may not notice are the side effects, because there are aspects of politics, such as being politically correct, and you're trying to put forth an ethical bot. Now, all of a sudden, it loses the context on how to become or give an ethical response, or maybe it's not as ethical, and it says something slightly offensive. These are the things that you really got to be careful of. That's an example of your scotch getting watered down. So keeping 5 iterations of your step down or watered down whatever of these blends of scotch will help you to go back to try to have a recovery point from which, much like in coding, when you do branching and versioning, it's the same thing, but it's a different, it's always history repeats itself. And again, these are the history repeating itself, but specific to AI. And obviously all of this is accelerated by at the edge because of the limitations of the power of needing to do things in real time and blah, 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 and everything that we talked about here. So it just brings all of this into light, into a very hypersensitive way. And also it just accelerates everything that you're doing, because edge is hard. It's not hard from an implementation standpoint. It's hard to tweak and tune and just find it and get it right where you need it to be, because you need that balance of optimization and horsepower and redundancy all baked into that. And that's what makes it really, really complicated, especially in manufacturing, when you got environmental issues. You know, if you're dealing with liquids, gases, solvents, whatever, things, you know, they're
or
fine.
just weather.
Yeah.
This is the reason why it has not popularized very much. So the technology really wasn't available until the 2020s. We had severe supply chain issues in the 2020s. And now technology is being able to fit in a smaller place. And the hardware, the cheap hardware, is getting more and more performant. So we will at some point cross that chasm where this will be very, very straightforward and cost effective. And I think we're getting there. And what I'm hearing, and the people I talk to and the clients we work with, and the industry experts that we rely upon, are all telling us the same thing, that this is something that is coming forth. Is it 2025? I don't know, but 2026, 2027, these things are becoming possible. There are more and more resilient hardware being created. There are data centers that are running at 90, 95 degrees, 100 degrees now. And that's really where we're going to go, is more resilient hardware, because that means you can, the majority of data center cost is actually in the cooling, not powering the equipment. Some people don't know that. And the more you can run hardware at a higher temperature, the cheaper it is to run it. So I remember Microsoft would put a whole data center and drop it in the ocean, and use the ocean currents to cool the data center. I thought that was interesting. But anyway, I think we've tangented enough. But, I think we've already kind of talked about the future. Things are going to get more and more feasible. Us as leaders, as transformation leaders, we'll be able to drive that innovation, whether it be improving efficiency or elevating those experiences that we talked about. And as time goes on, there will be more and more opportunities where we can bring the technology that only exists in the cloud out to the edge.
Yep, we all need to be good Autobots and not be Decepticons. Ethical AI.
Yeah, well, I mean, if you're using AI, you should be thinking about ethics. AI is for humans, not for computers,
This is
right?
true.
And as long as you can understand that, you can use AI effectively. I know a lot of people are trying to displace humans, and they find out that it's very hard to get the people who understand what needs to be done into the robot. And then somebody needs to make sure the robot's updated because the world's constantly changing. And you need humans to do that. And if the first thing you tell people is that they're not useful, then they're not going to help you.
Yeah. So, you and I were talking about backstage, offstage, not backstage, but offstage. A lot of things that's coming up that we're doing, cutting edge, pushing the boundaries, trying to, push things forward and make it work. So we realized that not only us, but you guys watching this podcast are also in the same position. So we love chaos. We live in it every day. We're constantly figuring out how to make things go or work. So if you get stuck, if you have an issue, you can find us, Sean and I, on LinkedIn, and hit us up, ask us a question, ask questions, or put comments in any of the multiple streams that we have that's going out there now. So that's pretty much it for today's show. I highly encourage, if anybody has a specific topic that you want us to cover, we're always taking requests as well. So make sure to also include those in the comments, because we do read every one of those. That's it for this week. Anything else to add, Sean?
No, I really appreciate all the comments and the interaction we've had on LinkedIn. Really glad to be part of such a community of leaders talking about the future and innovation.
Well, that's it, everybody. Thank you. We'll see you next Wednesday and every Wednesday at 12 o'clock noon Eastern Standard Time. That's it for today's show. Have a great day.